Oh wait, yes, ano di pa?
That's the one.
Okay.
Hey, that's my song. ये नजाकत मेरी आदत पास मुझे लाए नादानिया नादानिया खींचे मुझे नादानिया 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 पागल करे तेरी हर अदा शामों सुबह मैं तेरी याद करूं तेरे ख्यालों से मैं बात करूं.
Excuse me. Hi, do you know how to play this song, Nadanya?
हाँ भैया। नीचे रख दो ना।
ओके सर ओटीपी होगा।
हाँ, नहीं आया अभी तक।
आएगा। आया।
नहीं। हाँ अभी आया।
सुना है?
आया आया।
हाँ,
410863।
ओके सर करते हैं।
थैंक यू भैया।
Hi everyone, welcome back to another lecture of Computer Network series. Where we are going to learn about OSI model and layers in computer networks today. So let's begin with our first lecture, which is what is OSI model stands for. So basically, OSI, full form of OSI is Open System Interconnection. And this framework standardizes how data is sent and received across a network. So why we are learning this, we have already learned about different types of classification of networks based on coverage, speed, and all. But how this, while transferring data from receiver, from transmitter to receiver, how the data is being sent and received across a network, OSI model takes care all of these things. So the purpose of the OSI model is ensure interoperability. But what does this interoperability stands for? So this basically means uh, the ability of different system, devices, or application to work together and communicate, even if they were developed by different vendors or use different technologies. So when different devices made by different technologies, when they transmits and receives data, when they connects with each other, this is called interoperability. So in the context of OSI, it ensures the device and software following the same communication standards can exchange information without compatibility issues. So the only condition to for two devices to share information is they should follow same protocol. Protocol is nothing means the rule. So imagine two people speaking different native languages and English is a common language. So in the previous lecture also I have already taken this example that let's suppose there are two different people. One speaks Hindi and other speaks Tamil. So Tamil people don't know how to speak Hindi and don't understand even. Similarly, for the same issue for Hindi people also exists. So in that case, what happens? They both will try to communicate in English language, which is understandable to both of the people. So in this case, English is nothing but the protocol which both of these will, if follow, then both of will be able to communicate properly. So that was all about OSI model. Let's move on to the another slide where we will learn about what are the different layers of OSI model. So we already learned that OSI takes care of how the data is being sent or received. Okay. Now, from sending the data to receiving, so what are the different layers in between present? We are going to learn in these 7 layers. So the very first layer here comes is application layer. So always read from the end. So application layer where the user interface system. So just take an example of WhatsApp, in which the front page in the WhatsApp group we can see, or even if not WhatsApp group, if it is individual personal chat also. So the very first thing, the user interface which we are able to see is nothing but application layer. Similarly, in the presentation layer, whatever we sent, we already, let's suppose, sent a message to B. So person A is sending message to person B in WhatsApp. Okay, he sent a message here. Now, after sending the message, in the presentation layer, data formatting and encryption will happen. Encryption, why? Because in between, it reduces the fault tolerance. So even if some bad or the hackers want to steal our message, then for them it will be very difficult to understand that message. So that message after encryption is not in simple language that anyone can understand. It's very tough to understand. So that's why we encrypt the message in the
Ever wonder how a cat video travels from a server to your smartphone in seconds? Or how millions can watch a live sports event online simultaneously? That's the internet, a global system of interconnected networks. It's changed our world, but how does it actually work? From protocols to packets, let's dive into the inner workings of the internet. The evolution of the internet is a fascinating journey spanning several decades. It started with the ARPANET in the late 1960s, a project funded by the US Department of Defense. This was followed by the development of TCP/IP in the 1970s, which laid the foundation for modern internet. The birth of the World Wide Web in 1989 revolutionized how we access and share information. The 2000s saw the rise of social media and mobile internet, transforming how we connect with each other. Today, we're witnessing the expansion of the Internet of Things and 5G networks, pushing the boundaries of what's possible in an interconnected world. Now let's break down the key components of the internet. We'll start with the network edge. The network edge consists of end systems, also called hosts. These are the devices connected to the internet. They include desktop computers, servers, mobile devices, and an increasing number of IoT devices like smart home appliances. Hosts are sometimes divided into two categories, client and servers. Clients are typically personal devices like PC and smartphones. Servers are usually more powerful machines that store and distribute web pages, stream video, relay email, and provide similar services. Today, most of the servers providing search results, email, web pages, and videos reside in large data centers. These data centers can house thousands of interconnected servers, forming the backbone of many internet services we use daily. They reside in large data centers, search email, and provide similar services. Today, most of the servers providing search results, email, web pages, and videos reside in large data centers. These data centers can house thousands of interconnected servers, forming the backbone of many internet services we use daily. Next, let's look at access networks. These physically connect end systems to the first router on a path to other distant end systems. There are three main types of access networks. First, we have home access networks. These enable connectivities within a residential environment. They typically use technology like DSL, cable internet, or fiber optic connections to link homes to the broader internet. Then there are institutional access networks used by organizations and businesses. These are designed to handle the specific needs and requirements of large-scale operations. They often use high-speed fiber optic connections and complex network architectures to support many users and data-intensive applications. Finally, we have mobile access networks, which enable our smartphones to connect to the internet. These are cellular technologies like 5G to provide wireless internet access. The evolution of mobile networks has dramatically changed how we access and use the internet, making it possible to stay connected almost anywhere. Now let's dive into the network core. This is the mesh of packet routers and links that interconnect the internet's end systems. At the heart of the network cores are routers, specialized devices that direct packets from one network to another. These routers handle the task of packet forwarding, which ensures data reaches its intended destination efficiently. The network core operates based on the principle of packet switching. But what exactly does that mean? Let's break it down. When you send an email or load a web page, the data doesn't travel as a single continuous stream. Instead, it's broken down into smaller chunks called packets. Each packet contains a portion of the data along the information about its source and destination. These packets are then sent independently through the network. They may take different routes and arrive at different times. Once all the packets reach the destination, they are reassembled into the original message. This method has several advantages. It allows the network to handle multiple communications simultaneously, making efficient use of the available bandwidth. It also provides resilience. If one route is congested or fails, packets can be rerouted through different paths. There are two key functions performed inside the network core: forwarding and routing. Forwarding is the local action of moving an arriving packet from a router's input link to the appropriate router output link. It's controlled by a forwarding table inside each router. When a packet arrives, the router examines the packet's destination address and uses its forwarding table to determine which output links to send the packet to. Routing, on the other hand, is the global process of determining the full paths packets take from source to destination. Internet routing algorithms compute the shortest and most efficient paths between any 2 points on a global network. These algorithms take into account factors like network topology, traffic conditions, and link capacity to make routing decisions. One of the most important routing protocols on the internet is BGP. BGP is used to exchange routing information between different autonomous systems, large networks or groups of networks typically managed by ISPs or large organizations. In essence, BGP allows each AS to announce which IP address ranges it can reach, and this information propagates across the internet. BGP routers use this data to make routing decisions, choosing the best path for data to travel across multiple autonomous systems. The routing process is dynamic and adaptive. If a link fails or becomes congested, routing algorithms can quickly recalculate paths to ensure data continues to flow efficiently across the network. All activity on the internet involving communications between network devices is governed by protocols. Protocols are standard rules that define message formats, ordering of message exchanges, and expected responses. They are like the language and grammar of the internet.
So, like I was telling you guys, the OSI model is more of a reference, a guideline to help us delegate responsibilities, to help us understand what the communication process entails. And so I had you guys just list them out from top to bottom. But remember, the communication process entails both directions. Going down the stack is what we call encapsulating, and going up the stack we call decapsulation. And today I hope to explain why the encapsulation process is very critical to the communication. That is, to get the message from the sender to the receiver. Layer 7, layer 6, and layer 5 can be grouped in. In fact, the sole responsibility for the three of these is to produce what for the transport layer? Yeah. So by the time we get down to the transport layer, the PDU should look something like this. It should be in a binary format. So these three layers produce a PDU that we will call data. PDU is short for what? Protocol Data Unit. Depending on the application, all the encryptions and the compressions, these zeros and ones are going to be something that's really trivial. I mean, that's what network people see all the time, are just zeros and ones. They don't know if it's an email, or it's a voice communication, or whether it's a video stream. In fact, that's what we call the converging network, right? The digital converging network. This is why Time Warner and all the other companies can offer you phone, internet, and TV all on the same line. It's all zeros and ones. Once you get into zeros and ones, you need to identify that. Typically, on the application layer, we identify zeros and ones by a file extension. A .exe represents zeros and ones used to execute instructions. A .jpg represents those zeros and ones to display a picture or color, right? Likewise, we have identifications used in networking. Sometimes we call these addresses to identify the application working. Sometimes we call these addresses as a picture or color, right? Likewise, we have identifications used in networking. Sometimes we call these addresses to identify the application of the service. That's the first thing that the transport layer is going to do. The transport layer is going to identify what application's making the request and what service is going to receive this. Applications make requests. Services receive them. All right? So, the way we identify them is through port addresses. There's going to be a source, and there's going to be a destination. We stamp each and every one of the PDU for the transport layer with the source and destination. What is the PDU called for the transport layer? Segment. And why is it called a segment? Because what is the second thing? Or I should say, technically this would be the first thing. Yeah, it takes the data and it breaks it up into pieces, hence we call those pieces segments, right? So the PDU for the transport layer is called a segment. Why do we segment our data? Security, performance, and we can also allow multiple communications to occur relatively at the same time, which we call multiplexing, right? What was one of the protocols that defined the segment? Because remember, protocol data unit, right? So if we're producing a PDU, there's got to be a protocol that told me how to produce that PDU, correct? So what was one of the protocols? TCP was one of them. Correct? So what was one of the protocols? Produce that PDU, correct? A PDU, there's got to be a protocol that told me how to produce that PDU, correct? So what was one of the protocols? So if we're producing a PDU, there's got to be a right? Defined the segment. Because remember, protocol data unit, right? So if we're producing a PDU, there's got to be a protocol that told me how to produce that PDU, correct? So what was one of the protocols? TCP was one of them, absolutely. In TCP, we said time's irrelevant. I'm going to sacrifice time over reliability. Okay? This is why there's over-reliability. Time's irrelevant. I'm going to sacrifice time over reliability. Okay? This is why those big fat Cadillacs have a bunch of luxury items in there that add weight to the car, but a sports car, which is going to cost more than a Cadillac, I mean, if you're getting like a high-end sports car, probably going to trim all that fat because they want speed, correct? So what was the other protocol designed? UDP. TCP is the most popular one. All right, we passed that segment down to the network layer. And what is that network layer going to produce? What are we going to take that segment and make it into? A packet. And what is one of the most popular protocols on this layer that tells the operating system how to take a segment and make it into a packet? IP. And with IP, we have a source and a destination address. Much, much bigger than port addresses, but nevertheless, same principle. But what's the difference between these addresses? What does the transport layer use addresses for? They're both logical, but which one does what does the transport layer use addresses for? To identify what? They're called port addresses, but what do they use to identify? Services or applications. Because look above the transport layer. The transport layer is looking up and says, okay, who's getting this data? Who's getting that data? The way they know that is through port addresses. Okay? So what are the addresses used at the network layer? What are they used to identify? The key is network. What is the definition of a network? Two or more devices connected together, so they got to identify the devices on the network. So the sender and the receiver's IP address goes here into the packet. All right, so the packet gets passed down, and that becomes what? So we're in a data link layer, and we're going to produce what we call a frame. Remember, the frame is the only time we add a header and a trailer. And that frame uses, well, we could use all kinds of different protocols. I always like to talk the data link layer with the physical layer because its idea is to connect all that logical stuff. Now, the way I explained in my last class, and I got a kick out of it, but I think it clicked. Can you guys tell me what Internet Explorer smells like? I know you guys are going to say, well, it smells like shit because it's a piece of shit. But what about Firefox? What about Chrome? What do they smell like? What do they feel like? When you guys touch Internet Explorer, what does it feel like? Felt a little heavy, squishy. It doesn't have a smell. It doesn't have texture because it's all virtual. It's abstract, right? If I tell you what a 9-volt, if I ask you what a 9-volt battery feels like, you guys can tell me, right? That's down here. The physical stuff is what we touch, what we work with. So this layer is to take that abstract stuff and make it into something real. And we need standards. We need standards that tell me, okay, I can work with all that logical stuff. Give me all those zeros and ones, and I'm going to convert it into something that people can touch, taste, hear, feel. See. All depends on your interface card. Now I say hear, because if you could hear like my dog or beyond, you can hear the Wi-Fi network sending messages. And they operate at 2.4 gigahertz spectrum. That's well beyond our hearing, and you guys are going to be glad for that. I mean, the way we listen to FM radios, which are in the megahertz, is you need a tuner to tune into that frequency and then to tone it down to a range that you can hear, correct? Networks, we call them modems. But nevertheless, those signals are all over us. They're in this classroom all the time. I'm sending one from this microphone to my phone. It'd drive you nuts if you guys heard or saw all those things. But they do exist. The question is, how do I know that the interface card that I bought is going to work with my other devices on my network? There's got to be standards. Like when you go shopping for a hard drive, it says USB, or a flash drive, it says USB. You know you have a USB port and you expect it to work. So when you guys go shopping for interface cards or network devices, what are you looking for? When you guys go shopping for wireless cards or wireless routers, what do you look for? It says Wi-Fi maybe, but more importantly, it says 802.11 followed by a letter. So our latest one is 802.11 AC. In order to use all that bandwidth, to use that wireless router to its full potential, what kind of interface card are you going to need? An 802.11 AC interface card. So don't stop halfway and buy just a wireless router. Go the extra mile and buy the interface card that uses the full potential out of that wireless router. Clear about that? If I was setting up a wired network like we've been doing in Packet Tracer, you click on the computer, it says what for the interface card? Fast Ethernet. And that is a protocol or a standard that happens right here, the data link. Or a standard, Fast Ethernet. And the computer, it says what for the interface card? Fast Ethernet. And that is a protocol or a standard that happens right here, the data link. Ethernet has source and destination addresses, but they're physical. That means the company that made that interface card burned an address into that card that you cannot change. We'll get more into the difference between physical and logical. All right. Physical just takes those bits and produces a signal to carry them. That's it. Now, I tell my students there are other models that explain the same process. Some are less elaborate as this. One of the most popular models
Ever wonder how a cat video travels from a server to your smartphone in seconds? Or how millions can watch a live sports event online simultaneously? That's the internet, a global system of
Hey everyone, welcome back to another video, and in this video we're doing a complete computer
I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit. I got no love for the fakeness.
so instinctive and so passionate. Every word I move so descriptive like an adjective. I got a vendetta against people who patented being negative when you should be getting after it. I got facts over tracks, this and that. Spitting slow, spitting fast, I could roast, I could gas. Think I'm okay at last, but I don't know if that can erase all the past. And the pettiness, a reflection of the emptiness. Hilarious, you think you're worth my time, you're delirious. Mysterious, because you hide behind a fake exterior. Inferior, you know I'll always be a bit superior. Get off of me, this ain't no humble brag. I want you to hear words, you can say them back. I want you to feel free from the chains at last, and to believe in what you got, it was built to last, yeah.
Now that I've been put through hell, I never got anyone's help. I had to do it all myself.
I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement.
Gonna learn the consequence of being incompetent. Mental health is confidence, dreams and some modestness. I'm not here to save the day, that's for you to take away. I could play a million mind games, but instead I say something not illogical, something that is topical. Rub it on and watch it go, make yourself unstoppable. Dreams are irresponsible, but they're always possible. If you just believe, you could be so remarkable.
Thoughts in my head, a collage and they spread. I'll be great one day, going off of my meds. No, I'm not giving up, no, I'm not giving in. I will make it to the top, taking off in the wind. I gotta make it, I'm saving every day to taste it. I'm patient, but my mind, it can hardly take it. I'm chasing a dream that I've had for several ages. A vacant, modern kingdom for the taking.
Now that I've been put through hell, I never got anyone's help. I had to do it all myself.
I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement.
I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up.
everyone, welcome back to another video, and in this video we're doing a complete computer networking course which is important for the current boot camps that I'm running and the future boot camps as well, because if you're a developer then networking is important, how networking works, even if you're a mobile developer or a web developer, for example, or like we're doing the DevOps boot camp right now, right? So it's crucial, right? It's extremely important. So a little bit of like a motivational thing that I'll tell you is when I started with like computer science in my college, I had the thrill of like how things are working. So I used to look at like what is RAM, how does RAM work, how do computers work, what are the computer architectures, what happens when the computer starts up, how does the internet work, when I type www.google.com, how does it display the web page, what are all the internals and everything. So in this little story that I mentioned, there are a lot of components, how computers work, how this thing works, how that thing works, and so on and so forth. This is the sort of mindset you need to have if you want to be a great like developer and like be an extraordinary student, if you will. So in this video we're learning about how internet works, okay, computer networking. So please watch it completely. It's going to be a long video because it's going to cover like everything about how internet works. So we look at like what is internet, basic stuff, how it started, right? What were the early days like, how it has evolved over the years, and then technical deep dives. So what happens when you enter a URL? What is a URL? How it gets resolved? What is a server? What is a client? What is the protocol? What are the protocols? The OSI model, and how things are working in a story format. Because even though we'll be learning about the textbook stuff, obviously, but that is something everyone can teach. That is something you can find everywhere. One thing I'll try to put it in a way is make learning fun, as I always do in every single one of my videos. Storytelling format, right? So that you have fun while learning. So we're starting with the internet, and this is the complete DevOps bootcamp that we are currently going on. So you can check out the links in the description. We also have a complete data structures algorithms bootcamp for interview preparation. So for that, you can also find the links in the description, and then you can clear any FANG interview with that preparation. It's free. Everything is free. So make sure you check it out. All right. So when we talk about like computer networks, right? What does it mean? What do we mean by computer network? In simple terms, it's just computers connected together. Right, that's it. Someone in my college also, if they ask me some technical definition or whatever, right? Oh no, that movie Three Idiots, it's a movie, Bollywood movie. They ask what is a machine, and that guy literally like says a lot of things. I have never been that guy. I could not care less about the big definitions. Okay, what is computer? So there's the computer also has a full form, if you didn't know. Commonly oriented machine, particularly used for training, education, and research. That's the full form of computer. I memorized it because in my high school, my teacher, they used to ask us this thing every day. So anyway, what is a network? Computers connected together, that is a network. No problem, that is a network, right? Then what is the internet? So internet is basically a collection of these computer networks. Okay, so my computer is connected to my sister's computer, her computer is connected to someone else's computer, and our computers are connected to like the Wi-Fi or whatever, and that is connected to other people's computers, and sort of like this connection of computers connecting with computers. This connection is basically spread across like houses, cities, countries, so on and so forth. So this entire connection on a global scale, it's known as the internet. Okay, so I don't think I have to draw anything about it, but this is a network, computer A connected to computer B. Okay, if this is like spread across a large region or countries or whatever, everyone connected to each other, like whatever, like this is the internet. Okay, so internet is a collection of computer networks. Let's look at like we all know this, right? We all know what a computer is. We all know these basic definitions and everything. But let's look at what do we actually mean? Like how did it start, and how are they actually connected? That is what we are going to be focusing on this course. Let's look at how it all started. So let's talk about how the internet started. Let's go to the very beginning of this era. So what happened was that the Cold War was going on, and there was the United States and the Soviet Union, and they were like battling with one another, like who is going to be the very first. Okay, so when it came to launching the world's first satellite, so the United States and the Soviet Union, Russia, they were like, hey, who is going to launch the very first satellite? We want our names to be written in history, for example. So Russia won, the Soviet Union won. They launched Sputnik in around 1950s somewhere, 1957 to be precise. So that was the very first satellite. But now the US were like, okay, this is not cool. We wanted to be the first. So what do we do? How do we not miss out on further opportunities? Like, for example, we want to be the first to, step on the moon. We want to be the first on this or that or whatever, right? So US was like, okay, this is not cool. This is not working. We wanted to be the first. So the US government, they created a program, ARPA. So ARPA is known as Advanced Research Projects Agency. Okay, so they were like, hey, you are supposed to do all the scientific discoveries and keep our country number one. Okay, so what happened was that ARPA, they wanted to like have some sort of a way to communicate with each other. Okay, so ARPA had like facilities, they had their buildings or whatever. Okay, so they had their buildings in various parts of the United States. Okay, but they were like, hey, how do we communicate with them? It's becoming very difficult. Buildings are so much far away from each other. So they developed something called the ARPANET. Okay, so ARPANET was basically there were like four places where these computers, you can say, were. First was at like MIT. Okay, second was at like Stanford. Third was at, I believe, UCLA. And there was one more University of Utah. Okay, they were like connected to each other or whatever. Okay, something like that. So now basically this is what they had. So they were like, hey, we can now communicate with one another. We want to sell some files or whatever, whatever you want to do, you can do it. They were using TCP for this, Transmission Control Protocol. What is TCP? It's a very important topic. TCP, IP addresses, UDP, and the how simple mail transfer protocol. All these things will be covering in detail. Okay, so don't worry. TCP. Forget about what TCP is. Let me tell you what it like. What do we mean by these protocols and stuff? So basically, in simple terms, you are sending an email to someone. Okay, that may require some steps. Obviously, I'm sending an email to someone. It will require some steps. It will be like, hey, first send this email over here, then send this email to that person. They will then download it from the server, and then they will read that email or whatever that will happen. Okay, you want to talk to your friend. Okay, so you're talking to a friend. Hey, you connect with a friend, establish a connection. Then you send your video. They receive your video, they send their video, you receive their video, and you're talking on video conferences, and some of the frame rates drop or whatever happens when network is not stable, right? You want to send a file that is very important, and you don't want anything to be removed from that file while it's being transferred. Okay, you're like, hey, I want to send these special secret documents, and obviously all the data has to be sent, no data should be lost. Okay, so this is what you can say, different type of things I am trying to send over the internet. Make sense? Email, video, secure files, so many things. Different types of things I'm trying to send over the internet. So different types of rules will be required. Okay, there might be some rules set by someone. Hey, if you're sending a secure file, the internet should make sure that 100% of the data that you have sent to your friend will be delivered. If you're video conferencing with your friend, then the internet can drop a few pictures or frame rates because it does not matter that much. Okay, so these rules that are set up by people, how a particular data is being sent, these are known as protocols. Similarly, there's this TCP protocol, IP protocol, UDP, so many other things. Okay, now you know what TCP, IP, UDP and stuff, the category is. Individual Usually what it is, we'll look into later on. What is the difference between TCP, UDP, how email works and everything else. Okay, sound good? So this was like the very first computer, sorry, internet stuff. Okay, cool. This organization is still available, like they're still, like they have been renamed, but they are still in practice. Okay, so that's basically about it. And after that, as years progressed, more and more computers were added, more and more locations were added to the ARPANET, and that's it. Yeah, it started falling like TCP/IP. Just write IP over here as well. That's it. Okay, as simple as that. So right now we are in the very early stage of the internet. It does not have like really with like consumers or what, it's more like research focused. Okay, you're only able to talk to one another like this. Okay, via some protocols. We still use like TCP/IP, but how it has changed quite a lot, let's look into that. Okay, cool. So one problem happened was that as this was a research project, many people wanted to share their like research papers and stuff, which was not really working in this particular domain. Okay, so basically the idea was that I want to be able to share some documents that reference like some other documents or whatever. Okay, so what happens is that I want to send a research paper from MIT to Stanford, for example. This is a research paper. It has a link in it. This link is linking to another research paper. Okay, so this automated sharing, this was missing previously. Okay, so if someone is like, hey, MIT has sent me a document on about something like apples or something, and there's some other information about apples in another document. I need some sort of a way that I just click this link and it will point me towards that document, then that research paper or whatever. Comes into picture www, the World Wide Web. You must have heard about Tim Berners, right? So Tim Berners developed the World Wide Web. Okay, so World Wide Web is a project that basically stores these documents. Okay, you can store and you can access these documents via the World Wide Web. All right, you can actually check out the very first website that was created as well. Let me show you. Okay, this is the world's first website. info.cern.ch/hypertext/www.project.html. So don't confuse yourself with World Wide Web. Kunal, what is World Wide Web? Where is it stored? Okay, whatever. No, it's just a universal, like it's allowing you access to all these documents and it has all these links. Okay, if I click on technical, how to provide data. Okay, you have plain text files, you have shell scripts and things like that. Okay, you just have to make a server. We all know we'll learning how to make servers and everything. World Wide Web, you can see on Wikipedia as well. It's where documents and other web resources are identified via a URL. A URL like this, we all know about what a URL is, which may be interlinked by hyperlinks. There are so many links that are interlinked in this web page, and they are accessible over the internet. That's it. That is the World Wide Web. It's a collection of all these pages and everything. Okay, and it's published by web servers. You can host your own server. Okay, so now you know where all these things is stored on web servers. How servers work we'll cover later on. Okay, so URL and everything we'll talk more about later. But this is basically about it. This was the world's first website. Okay, this is it. But you will be like, Kunal, there's a problem here. There is no search engine. Like, how do I search for something? If I want to search for something, how do I search for it? You can't. You can't search for anything in this. So this option was not available. Okay, so to answer your question, Kunal, how did we search for things then? You couldn't. Okay, you just go to hyperlinks. From hyperlinks, you could save it in like some indices, but it could not scale to like, when there were like so many web pages coming up and things like that. So in the end, they had to develop search engines. Yahoo, I believe, was the very first one, but you can check out more about it, like in the history of search engines. You can go to Wikipedia and you can check it out. Then we had search engines, and now that's it. That we are now, in the history of internet now. Now a lot more things are coming up, like Web3 and things like that, and so on and so forth. Like I'm not sure, like where we'll head up, but where we're going. So yeah, that's the modern internet now. We have search engines and everything, but that's like the brief history. Okay, now let's learn about the protocols thing that I was mentioning. So you might have a question, Kunal, why even we want protocols? Why do we need these rules? So imagine you are making an application, okay, and someone else in some other country is making an application. You have some different rules about how your application can communicate with some other one's application. They have a different rule. Like I will communicate with another applications in a different way. So can you really communicate with each other? No. No, you can't. That is why it is extremely important to have like a set of rules and regulations. Okay, so these rules and regulations, who writes these? If I'm talking about I want to send an email, okay, so every single person who sends an email to another person across the world, that email is being sent using a set of rules and regulations. Like, okay, first this will happen, then this will happen, then this will happen. But who made these rules? Who controls these rules? Who creates the new rules? The Internet Society. Right now I'm just telling you all the cool stuff, but how it works, how the every step happens, that we'll cover later on. Okay, so the Internet Society, as you can see over here, this is the Internet Society, and they are the ones who are responsible for all these things. Okay, so how do we actually make submissions? We can do that by a RFC. RFC means, I believe, request for comments. Okay, so you can set a document like, hey, I have this idea about some feature of the internet or whatever. You can please, check it out. So you can submit it on this page. It's usually submitted by, very high professionals or whatever, but anyone can submit until and unless they have till they have an idea. Okay, so the Internet Society comes up with all these rules and stuff. You can learn more about them over here, internetsociety.org. Okay, so now let's talk a little bit more about some technical terms. We know like how internet started now and everything, but Kunal, you're mentioning about these protocols, right? right? The protocols and how the, like, we know what is happening, but we don't know how it's happening. Like, I know what the internet is, how it started, but we still don't know how it works. So before that, let's cover a few terms and stuff. So you may have heard about servers. Okay, what is a server? You may have may have heard about a client. So what is a client? So example, you have your computer, right? This is you have your computer, and you write here google.com. Okay, you click enter, it sends a request to the Google server, and Google sends back a response to your computer. Client, server. Okay, you write google.com. Again, this is a very broad explanation. Every single deconstruction of it, like a deep dive of how this is happening internally, what are the actual steps that are being taken, and I will actually make the picture clear in your mind how the internet works. Okay, a little bit of a spoiler alert. These various countries and various continents across the world, we are connected via wires. These wires are laid underground, under the ocean. That's how we are literally connected. So internet is not like in the cloud, it's actually under the sea. I'll tell you more how these things work internally later on. But the simple idea is, right now let's focus on what we are doing. Okay, then I'll talk to you about how we are doing it. So basically you write google.com. Okay, Google, this basically your computer sends a request to the server, Google's server. Okay, and the server gets that response. Server is like, okay, I got your response. I got your request. Here's what you wanted. There you go. Take all these things. It sends back a web page and a bunch of other things. A response is sent back to you. Okay, so does this mean that you cannot be the server yourself? When you're like, your own computer cannot be a server? It definitely can be. That is known as when you work on localhost and stuff. Okay, so your same computer can act as a server also and a client also. Okay, let's just give you an example of this. Okay, here let me write google.com. Web page loaded. How? What happened? So there's a bunch of things. Inspect element, inspect. So inspect basically shows me all the things. Network. I'll refresh. So many things happened. Okay, in this one request, these many things happened. Okay, a get request was made and get request was made and so on and so forth. And these are all the things, like status 200 means everything is okay and everything. So you got like HTML and you got like some JavaScript and PNG and HTML, JSON files and so on and so forth. So all these things we got back from Google and it created this web page. Okay, let's do a deep dive into this, like how this thing is working and how google.com gets resolved to IP addresses, or forget about IP addresses. Let's talk about what are IP addresses. Okay, what are these protocols and everything. And what is this like status code? What is this get? What is this, post and get? If I refresh it, you can see there's get, there's post. What is this method? What is this domain? What is this status code? What is this initiator? What is this type? And what does this mean by like this transferred? What is this B and KB? What is this size? What is this thing? What are these milliseconds? Everything will cover. Okay. So if you want to see all the HTML that we got and everything, and you can see like what is this thing, everything will cover right now. Okay, so let's do it. Okay, so before that, let's talk a little bit about protocols that I mentioned previously. So what are protocols? Protocols are just rules that are defined by the internet society. Okay, they're like, hey, these are the rules, this is how data is transferred and everything. Okay, so there are some like basic protocols. There's like TCP, which we'll look into details. Okay, so TCP is known as Transmission Control Protocol. Okay, so the idea is that it will ensure that the data will reach its destination and it will not be like corrupted on the way. Okay, so there's something you definitely want the person to get completely, you should use, it will be using TCP in your applications. Okay, there might be another. Okay, so there's something you definitely want the person to get completely, you should use, it will be using TCP in your applications. Okay, and it will not be like that the data will reach. Okay, so the idea is that it will ensure that the data will reach its destination and it will not be like corrupted on the way. Okay, so there's something you definitely want the person to get completely, you should use, it will be using TCP in your applications. Okay, there might be another examples like UDP. So when you do not care about if 100% of the data is reaching your friend or not, whomever you. So when you do not care about if 100% of the data is reaching your friend or not, whomever you want to send the data. For example, video conferencing. Okay, so not all data may be reaching, and that is totally fine by us. That is totally fine by us. Another one is HTTP. UDP means user datagram protocol. The next protocol is hypertext transfer protocol. Okay, this is being used by web browsers. The World Wide Web. Okay, hypertext transfer protocol. Okay, this is being used by web browsers, the World Wide Web. Okay, so it basically defines the format of the the data that is being transferred between your, like when we talk about www, so web clients basically and web servers. Okay, clients and servers. Okay, cool. So when a client over here in this, you can see, sends a request to a server, so these particular things like client sent a request to a server, server will send something back. All of these things are given inside HTTP. How the server will send back the data, that is also a rule that is given in HTTP. Okay, we'll talk more about that later. HTTP, HTTPS and everything. Okay, cool. So it's basically about it, but don't worry, we'll go into details of it as well, like how it works and everything. Okay, one more thing that we'll cover later on, and I'm just giving you a brief about, is how data is transferred. Okay, everything in online is like in computers, everything is 0 and 1. Okay, so it doesn't make sense to send the entire data at once. Suppose you want to send a large file over the internet, do you send the entire file in just one single go? No, it comes in chunks. Isn't that correct? Same things happen with these sorts of things, like when you're loading a web page, watching a movie online or whatever. Data you will be getting will be in packets. Okay, sound good? Let's refresh. So you can see these are like individual calls and you're getting different packets of data. All right, okay, so we have to cover about packets also. Packets are to be covered. There's one more thing. When you write google. Okay, so we have, so you can see these are like individual calls and you're getting different packets of data. All right. Okay. So we have to cover about packets also. Packets are to be covered. There's one more thing. When you write google.com, okay, how does it find which server to connect to or whatever? Okay. So basically these computers and servers, they are all identified via something known as an IP address. So you can think of it as your phone book. Okay. So in computers, what happens is that, in like phone numbers, what happens is you have your so many friends, right? You have, let's say, 200 contacts, and when you want to call someone, you just dial their name. Okay. Just like, hey, call mommy, and it will call your mom. Okay. Or call Sachin or someone. Okay. Anyone you want to call. Do you type their number all the time? No. So what is happening? Actual value is some number 9991119, something like that. This is being linked to a name. No. 200 contacts, and when you want to call someone, you just dial their name. Okay. Just like, hey, call mommy, and it will call your mom. Okay. Or call Sachin or someone. Okay. Anyone you want to call. Do you type their number all the time? No. So what is happening? Actual value is some number 9991119, something like that. This is being linked to a name. Okay. Name like John or something. You want to call John? You just call John, and it will directly dial this number. This is the same thing for IP addresses and stuff. Okay. All the devices that are connected together, you are watching me right now. Okay. You are connected to YouTube right now. Okay. So YouTube server. Okay. You are interacting with the YouTube server. So every single device on the internet that can talk to each other, they have something known as an IP address. Okay. IP address. So example, X, 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 X. This is a format. And every single X can have the numbers from 0 to 255. Okay. You write google.com. It will be resolved to a particular IP address. I hope it makes sense. What is an IP address? Okay. Sound good? So we'll talk in detail about IP address. There are like classes of IP address. Some are that are reserved, for example, okay, that no one can use or whatever. Okay. And how it actually like works. Cool. Sound good? If you want to check IP addresses of your own computer, you can do that as well. You can use the curl command, and you can use like the command curl ifconfig.me -s. You can use this command. It will give you your IP address of your the internet provider. Okay. So how does this work? Kunal, do everyone have the same IP address, or what is the IP address of my devices? If my device is connected to, if let's say you are at your house, you have a router, like a modem and a router, and you have like 4 devices connected to your Wi-Fi. So all these 4 devices, are they going to have the same IP address or different IP address, or how is it going to work? Okay, let's think about this. So this is how it actually works. This is your internet service provider. Okay, mine is Airtel, for example. Okay, internet service provider. Okay, your internet service provider gives you a modem or something. Okay, your modem and router or whatever. Okay, this is going to have a global IP address. All the devices connected to this Wi-Fi modem are going to have the same IP address for everyone around the world. Okay, for everyone. All the devices connected to this Wi-Fi modem are going to have the same IP address for everyone around the world. Okay, inside this modem, device 1 may be connected, device 2 may be connected, and device 3 may be connected. So the modem will give IP addresses to these as well. Okay, these are known as local IP addresses. Okay, these are known as local IP addresses. How does it do it? DHCP, Dynamic Host Configuration Protocol. This is also a set of rules and regulations only. I will talk to you about DHCP as well in the later of this course. Right now I'm just setting the stage, taking my time and just setting the stage. We'll cover it in detail. So modem, and it assigns these IP addresses using DHCP protocol. Okay, that's basically about it. Okay, so this is a global IP address. So if anyone wants to, if you make a request to google.com, Google will actually see this global IP address. So if this device 1 makes a request or device 2 makes a request, for Google, it will only be like, okay, this one single device is making a request. Okay, cool. Okay, and when the request comes back from Google, so this is connected to the internet. I'll talk about how ISPs work and everything later on. So you send a request to google.com, your ISP will send a request to google.com. Okay, it will return back the request. Okay, now this modem will decide, the router will decide who was the one who had the request. Was it device 1, device 2, device 3? It does that using NAT. Okay, Network Access Translator. I wrote it down over here somewhere, yeah. Okay, so like, hey, device 1 had Google Chrome open on its tab, and that is the something that requested this. Okay, sound good? Cool. Okay, but now modem and router is like, okay, I know device 1 was the one that made a request, but which application in device 1 made the request? How do we figure that out? You're running, let's say, MongoDB. You make some request and you want data to be you want the data to be back in MongoDB, or you're running your own server on your system. You make a request to the internet, and the data, when it comes, you want it to come to your own server or application